Welcome to Liana series of episodes. Today we have the pleasure to host Arlind. Arlind is a doctoral researcher at KTH University in Stockholm. He holds both a deep comprehension of computational technology as a genuine concern for global regeneration. Trained as an architect, he found himself lacking a framework to guide digital regenerative design, and he took on the challenge of building it. In this episode, he introduces the overall regeneration approach, key performance indicators applicable to the built environment, a general dive on digital regenerative design, and the limits and potentials of the process. Get ready to look through the eyes of a mind as lucid as structured, cutting the edge of data technology at the service of global prosperity. Arlind, thank you for joining.
Thank you so much, Sarah and Melissa, for having me.
It's an honor for us to have you as a guest today. So let's deep dive into the subject. The first topic we want to touch with you, it's regeneration beyond sustainability. So Arlind, could you tell us what is the widely known definition of sustainability?
Yes, perhaps the most widely known and currently in use definition is the one that comes from the Brundtland report, or Our Common Future. And that's quietly outdated. It comes from 1987, and it states that is development that meets the needs of the present without compromising future needs to meet their own. And we could argue that this is mostly human-centric definition of sustainability and does not take so much into account planetary health.
So for you, is it a sufficient approach for the challenge we are facing? And why?
Well, we've had since then, also before, a lot of different frameworks, or for example, in the building industry, the so-called green buildings that aimed to make construction and design more environmentally friendly. And the built environment is responsible for a big part of carbon emissions in the atmosphere, and also for a huge use of resources, and also for generating, again, a lot of waste from construction activities. And as the years go by, the climate challenges are growing, and also tackling these challenges becomes more important. And the approaches that we've had along this time apparently have not been enough to solve the issues that we are facing. Yeah.
So now, knowing that context, we would like to know what is regeneration.
Yes, so regeneration is a concept that actually means sustaining life itself in all of its forms, so human, but also biodiversity and planetary health. And regenerative methodologies come from, it's a practice that comes from a few scientific and also practice authors. For example, we could look at the work of Regenesis Group and also John Tillman Lyle, which are some of the pioneers of regeneration. And the difference with sustainability is, while sustainability looks at reducing environmental impacts and making a design or a building or a community that is more efficient in the way it uses resources, the goal of sustainability is to go beyond this mindset, but to look how we can actually not only operate and maintain a city or a building, but improve and the life supporting systems, but also regenerate. So supporting life along for human and for nature and towards coevolution. So because life is always changing, it's a dynamic process. It's not static. It's not a point in time.
And why is it so important? The regeneration
to change this way of understanding, to go beyond a human-centric approach to a holistic approach.
Yes, yeah. Yes, in the end, if we think of any organism, if it does not change anymore, in the end it dies. And the same happens with our built environment. It needs to change, it needs to adapt to the climate, to the local climate, it needs to adapt to changes that can happen within the area, its watershed, and changes that can happen to society, to culture. So that's what coevolution means, and this aims to go beyond the current approaches that we have to sustainability. that are focused mainly on this having like a checklist of what sustainability is and tackling separately challenges, while regeneration is more holistic, more looking at the broader regenerative development. And then regenerative development informs regenerative design, which concern a particular area or a building.
Okay, thank you very much. Now that we have a clear idea of what is regeneration, we are going to start with a new part, the pillars of regeneration and the KPIs. So can you tell us which are the pillars of regeneration, please?
Yes, so my research started as a related, for example, we know in sustainability the three pillars: social, economic, and environmental. And there's research that argues that these three pillars have become commonplace, and maybe there's not a strong theoretical basis to it, or maybe there are more pillars. And in other authors on regeneration have argued that the three pillars are climate, so designing with climate, designing with people, and designing with nature. And it aims to bring also looking at the place specific, so designing with climate, and there's like approaches like bioclimatic design, designing with nature, so bringing the design beyond the scale of the building, but also understanding what is the area and that is inserted, any kind of development, and how it connects with the larger patterns of the place. And also designing with people, so it requires to engage every stakeholder, not as something that they have different interests that they could collide, but how they could be somebody that have stake interest in an area that could create a development that has improved and enhanced the potential and of that place. So this is what the difference, and this is what intrigued me also to think of, instead of looking at these three pillars of sustainability, looking at designing for regeneration, looking at these other pillars, which could improve also the clarity of, but we could go deeper into that later.
Okay. And in terms of measures, which KPIs apply in general for regeneration and then for the built environment?
Yes, so for example, usually when we think of those three sustainability pillars, environmental performance, it's usually performance of buildings, while this way that I'm proposing in my research is that in the climate pillar, it's usually metrics and indicators on building performance, because the building needs to operate within a certain climate and a certain context. While metrics and indicators on people, they focus on usually metrics that aim to provide comfort, but also metrics that go beyond comfort, that aim to provide well-being, for example, either through daylight or post-occupancy evaluations, or also the use of smart building technologies, while nature is trying to bring this clarity. So how are we using nature's resources? Are we being more environmentally friendly, conscious, and more in that way, and more circular in how we use? And that's where all these approaches to circularity of water in the use of resources of and also of building materials come into play.
Okay. So how generally can we measure the progress, and how can we be more proactive into this field?
Well, that is not an easy question to answer, but for example, the first regeneration requires the engagement of everyone, especially in a development, and not and also to rethink the role of designers. It's not just anymore someone who designs a building, but is someone that engages and first starts to understand the place and the location. That needs also to involve the other stakeholders in the process. And once we do that, we could then work with what is the potential and what is the best thing to realize in that particular context. From a personal point of view, and it's not all, and that's the challenge of regeneration, because it requires to engage people, but also requires to go beyond design and construction. So it does not stop with the construction of something, but it's something that should be continually seen as a continual dynamic system, the building, the community, and so on. I found personally this way of relating the developments in Industry 4.0 and in technology with the regeneration, while anyone has to find their own way how they would connect and how they could contribute. It could start with their communities, it could start with their environment, it could start with your own daily life activities, like not staying closed in an environment, but also going outside, because light plays an important role in our health and also how we use our own resources and how we live every day and how we relate also with other people.
What you just said is very interesting because, as a matter of fact, each stage of the building life cycle is connected in a certain way, and Industry 4.0 allows us to keep track of those indicators all along the life cycle. And we can link with this to jump to the next chapter, which is computational regenerative design. As far as I know, regeneration has been for some time now. I mean, it's not a new concept. It's not a breaking new topic in the academy, but you chose it for your research because of the role that Industry 4.0 can play in that field, right? Because
Yes.
data technology provides us with tools to keep track of that information and to understand the issue in a holistic way, in an integrated way. So the first thing that I would like to ask you for a general audience is, can you explain to a general public how can data technology help us in being more regenerative and in measuring our progress? How can data technology help us in this field?
Yeah, so maybe I will start with a general premise. So regeneration is methodologies about designing the built environment, but it's also expanding to our other fields like regenerative travel, regenerative fashion, because all aspects of human activities can have an impact on the planet. So it is really about harmonizing the human activities and not degrading anymore the environment. And when these methodologies came up, they were based on methods, tools, techniques that were well established and scientific, but at the same time, we did not have the digital technology that we have today and that has matured. So, and a lot of when we had these green buildings, a lot of the metrics and indicators that we could tell if the building has a good carbon footprint, has a good daylight, has a good consumption of energy, they were mainly just building metrics. But now all these methodologies, there comes new research along and understands that daylight is not just about how well can you read or how well can you perform a task, but daylight also has a big influence on your well-being, on your sleep, or on your productivity, on making you happier and so on. So, and all what the research tries to do is how much to quantify these benefits or not. They are evident. We like to have a view outside, but how much does that change the design, or how much does it actually improve the visual comfort or the well-being and so on. So and also since and at the time metrics were not so mature and green buildings was criticized, but now these methodologies are expanding, so we can look at a lot of these technical aspects without knowing very much the details, but we can look them at an urban scale. So a lot of these digital data really comes from a very larger scale, and then it goes down to the building or to the single space. So since these are changing, this is what my work tries to acknowledge and to capture, that they go from a larger scale down to the smaller scale, and these can inform the different steps of the development to make it, and of the design of a building to make it more regenerative.
Okay, so if I understand well, the combination of regeneration approach and Industry 4.0, their combination allow us to expand the scope of the variables that we are considering and be more inclusive when designing, be more aware of the implications of our choices in in aspects wider than just building metrics. I
Yes,
mean,
yes,
the
yes.
combination of data technology and regeneration allow us to increase our scope, to increase the variables that we take into account when designing. Okay, you just mentioned something very interesting. You talked about technology maturity. I'm not sure if you said data, I mean, the maturity of the market, but I would like to ask you, how mature is digital technology when it comes to digital regenerative design?
Yeah.
I know it's a tough question, maybe, because it's not a quantitative one, but how mature would you say that technology is right now in this field?
Well, technology has developed immensely in a sense that even when we design, we can have a lot of it cannot substitute the understanding of being in the place and meeting with people and understanding what are the real needs. So there's something that technology cannot substitute, but at the same time, it can put to the table a lot of data that we can get from the place, like understanding what are the different services. We could get a lot of things from data. What are the distances? What is the safety of spaces? Something, and a lot of things are becoming more measurable and quantifiable. But of course, they also need to be cross-checked with the real presence of people and discussions. But data can bring a lot to the table to have different discussions from an very early stage of development or of a single building, and understanding how this thing influence, like the 15-minute city in Paris, or what is the transportation and services of a place, and that can be very easily evaluated with data, and there are methodologies and tools that can actually do those right now.
Okay. I think that's a wise thought, to say that, okay, so data can help us, but data cannot replace the presence of a person in a place. I mean, there's a part of our duty that cannot be completely replaced by digital repositories. So I think that is very wise. Thank you very much. Another question that I wanted to ask you, you talk about city scale, neighborhood scale, and building scale. In terms of technology, are there any differences when it comes to dealing with urban scale than when dealing with a building scale, or are they the same in technological terms?
Urban scale, it means that we are perhaps working with one or more building for design or for using, but also looking at taking into account how the other buildings and how these other flows of people, of the nature, of the wind, of the light, how they could inform and guarantee for both. So for the existing and what is happening, what is changing in that place, how we can actually improve those. And while sometimes we would think of only a building design, if you take this broader scale, we can take into account not only our design to make it better, but also to still guarantee for the other buildings if they can have a good ventilation or a good daylight inside.
Okay.
And that's why we need both of these scales to integrate.
Okay, I can see. I mean, the problem you are solving is different depending on the scale. Because if you are focused on a urban scale, then you may be more focused on people workflows, on sanitary systems, on drainage systems, and so on. Okay, I get it. So it's not a matter that the background process of technology are different. It's not that, but it is just that the problems you are trying to solve are different depending on the scale. Okay, can you tell us a bit about the case study that you exposed in your research? I think you focused on a housing fund in Slovenia. Is that right?
Yes, it was a project of the Housing Fund of the Republic of Slovenia, a residential development for young people, but also for people of different ages to create and affordable to create this community of different people with different size of units. So and also to have also co-housing units. And this was the case study. At the time, it was under design, not constructed yet. And my work was also to test these different performance aspects that go from the climatic aspects of design of the local climate to the more digital aspects and what is the building performance, also looking at the site, but also at the single building and the single units. And these I used also for developing the framework, so also testing a lot of tools, but also testing a lot of workflows, like building information modeling and computation, and selecting what could be more appropriate for within these limitations of regenerative design, so to say. And this was the case study. And that also was shared with the housing fund. So what were the results, and that could also inform further work of them when they need to do the tendering process of new projects, or when they need to select offices. So they could include, for example, additional criteria that the design needs to evaluate a project proposal. So not only if they can achieve certain square meters within a certain budget, but also if they can guarantee a certain life cycle assessment, energy or daylight of a building or of a district. So.
Okay, it's very interesting. So you developed a framework that included a set of indicators that could be evaluated to take into consideration all these holistic aspects that we are talking about when it comes to regeneration. Okay, and you used them to study that design, which was yet to be built. Performance is something very important for developers as well as for owners. So I would like to ask you, what happens if we use data technology to estimate the performance of a building in a certain aspect? What happens if we use data technology to estimate the performance, and then reality says that the performance is different? What happens in that? Is that common? How do we deal with that?
Yeah, so any methodology that we have today, it's our standards or regulations, they try to predict what will be a certain outcome of and there's never 100% certainty that what we predict will actually be the same. Like even in a rendering, something may look in a certain way, but when it's built, people may have a different opinion if they like the project or not. And with building performance, this is something that is called the performance gap. So there's a difference between how it actually performs the building and how it actually was predicted or calculated. And this is something mostly used for energy, but not only. For example, for energy consumption, we can say a certain amount, but then the building can consume less, but there are also cases that the building can consume more energy. So both can happen. And that can happen for a variety of causes. One could be climate. Other factors could be how the actual building is used. But it also goes beyond energy. So it could be how the actual could be based on the carbon emissions, life cycle assessment, or could it based on other performance, or how comfortable the outdoor and the indoor spaces are. And of course, we need to be dynamic. So when we find these things, we need to design buildings that can be adaptable to changing needs in the future, but also to more changing needs from the local climate or changing needs of the users. So adapting the floor plans or the so-called more adaptive or circular facades, which can be through different using of sensors or using shading elements that can move, or using, for example, different landscape elements that could, for example, improve the outdoor climate. So it becomes less windy, or people are shaded if they need more shaded during the summer months in a hotter climate, so to say. So I'm saying it very shortly and condensing it for the audience.
No, but it's clear enough. This concept of performance gap, I think that's very important, because users usually get the idea that the answers to their questions are precise, and they are not, because as you say, there are many factors that might change, and we have to be agile enough to adapt. Because as a matter of fact, when it comes down to electric consumptions, for instance, there's a high impact that goes that depends on the user behavior, on how you do behave inside the building. That has a high impact, and that behavior cannot be considered when simulating. Or weather conditions, they change from what you thought they were going to be. So I think it's important to strengthen this concept of performance gap, to let people know that data technology can provide us qualitative answers, or maybe quantitative answers, that get preciser as we get closer to the real conditions when simulating. But it's important for our audience to know that there is a gap between what we simulate and what reality finally says. Thank you very much, Arlind.
Thank you, Sarah and Melissa. Thank you too.
So this is one of my favorite part of our episode, the call to action. So considering all what we have been discussing the last 13 minutes, how do you think, Arlind, that our audience can engage with an improvement related to regeneration, Industry 4.0, and awareness in general for citizens, companies, regulators, entrepreneurs? How do you think they can engage?
Yeah, well, working with data is a new way of designing buildings and doing things, but I'd like to borrow it from Meng and Reed, that are two authors that have written and have worked in the practice of regenesis, that they say that regeneration requires a different worldview, so it requires a new mind and a new way of being. If we are to solve the problems that we have ahead, and also to create a better future, and not solve it with the same mindset and worldview that created it, the mechanistic, but with a more ecological and a new mind to solve and to approach things that we need to. And that's the call to action. Have an open look and have an open mind to changing your thoughts and trying out new ideas and beliefs.
Okay.
Yes.
That is a good one. We have never heard that one. Okay. Thank you very much, Arlind. It has been a pleasure having you on board. I was afraid that we will not be able to explain this topic in a generalistic way, but you were absolutely inclusive in this field. So thank you for that, because it's hard to explain things in a general when you know about the topic as much as you do. So thank you for that. I hope you found this interesting, and see you soon.
Yeah, thank you.
So